The wind is everywhere. It slips through narrow streets, rushes over open fields, and climbs the sides of tall buildings. It carries whispers from distant places, unseen yet undeniable. Every day, it holds enough power to light the world many times over, yet most of it passes us by. On rooftops, we invite the sun with solar panels, but the air above remains untouched. Why have we learned to capture light, but not the breath of the sky? The answer lies in design, in patience, and in daring to reimagine what moves all around us. The promise of wind. Wind is one of the few forces on Earth that never rests. It is older than mountains, shaping valleys and carrying seeds across oceans. It drifts softly through the stillness of dawn and roars with strength in the middle of storms. No matter where we stand, the air is always moving, always reminding us that the planet is alive. Hidden within this endless motion is energy beyond measure. Scientists estimate that the wind contains far more power than humanity could ever use in a single day. Imagine for a moment if we could reach into that current, if every passing breeze could light a home, cool a room, or charge the devices in our hands. The scale of possibility is staggering. What makes wind even more remarkable is its generosity. Unlike coal or oil, it leaves nothing behind but the memory of its passing. No ash, no smoke, no damage to the soil. It does not need to be mined, drilled, or burned. It simply arrives, clean and constant, asking only that we pay attention. Yet most of us live surrounded by this gift without truly seeing it. We cover our rooftops with solar panels, embracing the sun's fire, but the air above those same roofs flows by untouched. Far away, in rolling fields or out at sea, massive turbines rise into the sky, capturing energy at an enormous scale. But here, in the places where we live and work, wind remains untapped. The promise of wind is not only its abundance, but its closeness. It brushes past our windows, slides through the streets, and waits above every roof. To honor that promise, we must learn how to shape it, how to draw the vastness of the sky down into the rhythm of our own lives. Why rooftop wind failed before. The idea of catching wind from rooftops is not new. Small turbines have been tested for decades, promising clean power for houses and apartments. But the reality has often fallen short. Blades on these small machines bring noise that rattles through walls. Vibrations travel into beams and ceilings, leaving an unsettling hum. Neighbors complain, and the quiet of a home is disturbed. Wind in cities is also restless. It swirls between towers, changes direction without warning, and often weakens near the ground. A small turbine built for open fields cannot handle the chaos of a crowded skyline. Instead of steady power, it delivers bursts and gaps, stressing the machine until it breaks down. There are other barriers too. Many rooftops cannot support tall masts or spinning blades. Some people see them as eyesores, interrupting the shape of the buildings around them. For birds and bats, even the smallest blades can be deadly. Because of these problems, rooftop wind has remained more of a dream than a reality. Solar grew while wind waited outside, untamed and unwelcome. To move forward, a new design would have to rise, one that avoids blades, reduces noise, and fits into the lives we already live. The Aeromine vision. A new approach is beginning to shift the conversation. Instead of spinning blades, Aeromine offers a system that stands still. At first glance, its design seems almost too simple. Two tall, hollow wings rising from a rooftop, facing each other across a narrow gap. Nothing moves on the outside. No blades, no whirring noise. Just silent structures waiting for the wind. The secret lies in what happens between them. As air rushes past, it is drawn into the space between the wings. Pressure falls, currents accelerate, and the flow is guided downward through small openings. From there, the wind travels through a short channel to a hidden turbine placed safely inside the building. This shift changes everything. The parts that move are sheltered from weather, protected from hands, and invisible to birds. With no blades exposed, there is little risk and less need for maintenance. The company also says it can start turning at lower wind speeds, where traditional turbines would stand still. The inspiration comes from racing. Engineers learned long ago that the same airfoils that lift a plane can be flipped to press a car down to the track. Aeromine borrows that lesson, shaping the wind into a tool we can finally welcome onto our rooftops. Physics beneath the surface. To understand how these quiet machines work, we have to look at the hidden rules of air itself. Wind is never just empty movement. It carries patterns, forces, and pressures that shape the world around us. One of these rules is known as the Bernoulli effect. When air flows quickly over one surface and more slowly over another, the pressures on each side become uneven. This difference creates lift, the same invisible push that holds an airplane in the sky. For a turbine, that push becomes motion, which then becomes electricity. Another rule is the Venturi effect. Picture water racing through a narrow pipe. Its speed rises as the space tightens. Wind behaves the same way. When air is guided into a smaller channel, it accelerates, gaining energy that can be captured. Both Aeromine and other rooftop designs use these effects. They do not fight the chaos of wind. They shape it. By guiding air into carefully formed paths, they pull power out of the invisible. No blades slicing the sky, no towers cutting across the horizon, only hidden pressure, captured and turned into light. It feels less like building a machine and more like learning to listen to physics itself. Comparing Aeromine and solar. Solar panels have become the symbol of rooftop energy. They are simple, predictable, and proven. Place them in the sun, connect the wires, and power flows. Wind has never matched that clarity, but Aeromine claims it can close the gap and even surpass it. The company says one unit can match the yearly output of many solar panels while using far less space. If true, it would allow rooftops to produce more power without covering every inch with glass and metal. It would also mean energy at night, when the sun disappears, but the air still moves. Yet questions remain. Data is limited, and the technology is still in early stages. The numbers shared so far are promising, but not yet confirmed by years of use. Cost is another unknown. Building solar has become cheaper every year. Can Aeromine compete with that steady decline? For now, the comparison is more a vision than a fact. Still, the possibility lingers. Imagine rooftops where wind and sun stand side by side, filling the gaps for one another. The thought alone is enough to wonder if rooftops could one day provide all the energy a building might need. The PowerNEST example. In the Netherlands, another vision of rooftop wind has already taken shape. It is called the PowerNEST, and it looks less like a machine and more like an extension of the buildings it rests upon. Instead of placing turbines on poles, engineers built a raised frame that covers the entire roof. Beneath it, small wind turbines are hidden, while above, solar panels stretch in neat rows. This design uses the city itself to its advantage. Wind rushing around tall structures is drawn into funnels, which speed it up before sending it to the turbines below. The air then slips past the solar panels, cooling them and quietly boosting their efficiency. In this way, two technologies share the same space and even strengthen each other. What is striking is not only the performance, but also the acceptance. Tests showed no disturbing noise, no shaking walls, and no complaints from the people living below. Birds passed unharmed, as though the structure were simply part of the roof. PowerNEST reveals something important. Rooftop wind does not have to clash with daily life. It can blend into it, turning city skylines into silent partners in the search for cleaner power. The bigger picture. Every form of clean energy carries its own strengths and weaknesses. Solar shines in daylight but fades at sunset. Wind flows at night but can fall still without warning. Neither is perfect alone, but together they create balance. One fills the silence left by the other. That balance may be the true promise of rooftop wind. It is not about replacing solar, but about standing beside it. A warehouse roof, a hospital roof, even a tall apartment tower could host both, feeding power through the same lines into the same lives. The more diverse the sources, the steadier the supply. And diversity means resilience. When storms strike, when grids falter, when fuel runs short, buildings that produce their own energy can stand stronger. They become islands of light in the dark, sustained by sun and air. Seen this way, rooftop wind is not just technology, it is a step toward independence, toward cities that breathe power from their own surroundings. Quiet machines working side by side, turning invisible forces into something we can hold, something we can trust. That is the larger picture waiting just above our heads. Wind has always been with us, yet we have treated it as background noise. Now, designs like Aeromine and PowerNEST suggest another path, one where rooftops hum quietly with their own breath of power. These machines are not loud or imposing. They do not demand the sky. They simply listen to what is already there and give it back as light. The question is no longer whether the wind has enough strength. It always has. The question is whether we are ready to invite it into the places we call home.